Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a guest that's on for the second time. His name is John Williams. We've had some people on for 3 or more times on the podcast. It's been about a year and a half. February of 2024 is when John was on the first time. John is the chairman and CEO of Viridi Parente, and he is up in Buffalo, I believe. Is that correct, John?
That is correct, Sean.
And so what's been happening up there in Buffalo for the last year and a half? What did I miss?
Well, you missed a lot of snow, which, we'll get that out of the way on Buffalo right now. You missed that we didn't win the Super Bowl, so we'll put that aside as well.
Maybe we could go back and change that. We'll find some technicality and give it back to you. How's that sound?
That would be much appreciated by the entire community. So they probably build a statue to you right next to Ralph Wilson, who brought the team to Buffalo. So
okay, I'll be working on that. All right.
That's good.
I'll have to go check out that statue too while I'm there. But yeah, I remember going to Buffalo a few times over there by Niagara Falls. I guess Nikola Tesla was powering Buffalo before I think any city was powered by a single source, Niagara Falls, with his really strange two-phase electricity, not single-phase, not three-phase, two-phase, however that works. I'm not really teaching that because nobody does two-phase. In fact, I couldn't even draw a diagram of it. It would just be pretty weird. So Nikola Tesla was famous for feeding pigeons. I think he did some other stuff too, but I think there's a statue over there with him feeding pigeons, I think, over by Niagara Falls. Have you seen it?
Well, so right in Niagara Falls, he's holding a textbook, sitting in a chair, and it is a favorite spot for pigeons to gather.
Okay, maybe I saw a live pigeon.
Live pigeons on his statue. So we could digress a little bit on that point, right? So Nikola Tesla and George Westinghouse partnered to build the first alternating current generation facility in the country, which was the Niagara Hydro Project. And at the time, Edison was the biggest competitor to them because Edison was pushing direct current. So you kind of had this competition of technologies emerging in the U.S., and Edison, because of who he was really gaining traction across the country with direct current systems, even though alternating current was a vastly better technology. And to your point, at that point, it was only two-phase. The turning point in that kind of commercial fight was the Chicago World Fair, because in Chicago at the turn of the century, Tesla won the contract to build an alternating current generator to power the fair, which was literally called the City of Lights, because it was the first time you didn't have arc lighting, you had electric lighting, electric AC lighting up the fair. And it's a really cool story. Like if you ever get a chance to read that, it's in a historic fictional book called Devil in the White City, which wraps a lot of story around it that happened, but it's a fascinating kind of review of Edison and Westinghouse and Tesla fighting out the commercial viability of how electricity was going to be generated and delivered.
Great. And so you were saying arc lighting was competing against electricity? What's arc lighting then?
Well, so arc lighting is DC. So the way they would create lighting was you would send a DC current essentially into an arc. And the electricity passing from the positive to the negative had illumination, and that was how they created lighting.
Okay, cool. So you can't do that with alternating current, I guess.
You can't, and obviously because alternating current goes into something and creates lighting, it's way safe because the arc is encased inside of a bulb. But arc lighting you couldn't encase. You just put a mirror behind it, and you created an electric arc.
Oh, great. Okay. Well, let's do some more of that with your technology. I sometimes wonder too, is if Tesla and Edison were battling it out right now, maybe Edison and his DC would win. We're kind of going back to
the future, right, John? Because DC current is so much more efficient to move, most of these big grid scale transmission systems are going back to DC.
Yeah, like HVDC, high voltage DC, and with alternating current, you have skin effect. So the current goes around the outside of the wire when you're sending large amounts of electricity. And with direct current, you use the whole cross-sectional area of that wire.
So you are reverting to your electrical engineering background, which I very much appreciate.
Yeah. And then the other thing too is with DC is it's like batteries, solar cells are DC. My computer has a converter that makes it run off of DC. My car has a big battery in it that's DC, but it actually does use AC to spin the wheels.
Yeah, and that's because the material that we have in our supply chain is all based around AC drive.
Yep.
So even though we want the motor to be powered off of DC, we can only source products that run on AC. And to what you just said, we then do a conversion, we lose energy in the conversion, and we create a bunch of stuff that probably we don't need. So I think over the next 20 years, you're going to see this shift back to DC componentry. It won't replace AC, but you will see more DC conversion to AC for limited purposes than for most of our electrified devices that we're bringing into the economy.
Yeah, I know that they say inverters, when they first came out with inverters, they were variable frequency drives that they turned into inverters. And I guess that's with an electric vehicle too. You have the DC battery, and it's easy with the alternating current to speed it up and slow it down, like variable frequency. Yeah.
Yep.
And it goes pretty fast, and it's pretty fun too. All right, we're having too much fun here, which is good. You know, people are listening, people are learning. And so what else is going on? Like, what have you been doing for this last year and a half at Viridi Parente? And maybe you can just remind people of what you do and what Viridi Parente does.
Yeah, that'd be great, Sean. So I think the last time we talked, we were in the middle of a couple initiatives. One of those was to fully finish and commission our automated production lines. So in Buffalo today, we have 2 fully commissioned automation lines that can produce about, 200 megawatt hours of pack systems annually, each line.
So that's batteries.
That's batteries. So we can produce today just under a half a gig of our 50 kilowatt hour pack system on a fully automated production line that starts at the cell. So we feed single cells into the line, an 18650.
Oh, that's what I have. I have 7,000 in my car, 7,000 of those. Yeah.
Okay, so we put 4,320 in a pack, 50 kilowatt hours. And out the other end comes a fully developed pack system that has been QA/QC'd, cycled, and is ready to go into a product.
Great.
And that allows us to, not only scale the technology, but deliver a much more consistent, much more cost-effective product to our customers.
Great.
We finished that. We went through UL, so we've now been UL certified on the line, and we have UL 9540 on the product. So we have a full UL listing. We have full ISO 9001 on the facility. And then we took all that and we moved it to California and did it again.
Oh, great.
So we are now in Richmond, California, just outside of San Francisco.
I'm in the same county. Yeah.
Okay. So we're at about a 40,000 square foot facility at the old Rosie the Riveter Ford plant.
Is that where SunPower was?
Well, that's where Moxie and Power was.
Okay, because I did some SunPower training there with a famous solar instructor, Mark Moroz was one of the instructors. And at the SunPower factory, I'm pretty sure it was at the Ford plant. It was this big brick building.
That's the one. It's a multi-tenanted facility. Mm-hmm. And there are, there's clothing stores and factories and food service people. So it's about 1 million square feet of industrial space that has been, has different uses. We're in about 50,000 square feet, which was the old Moxian facility that we kind of took and reconfigured.
Okay, and that's got a lot of really cool history. So it was like Ford. Then I think they started building Liberty ships there during World War II.
Yeah. It is actually where Rosie the Riveter was photographed.
Yeah. Oh, it's where she was. Rosie the Riveter is not just a cartoon, a real person.
No, it's a real person, and there's a whole museum to kind of the war effort that went on there. So it really is. And for us, we're in a similar facility in Buffalo, which was a former GM plant that was built in, it was commissioned in 1920. So it turned 100 years old recently. And it was also used in the war effort after it was, it built cars, it built tanks, it built all kinds of stuff. So it's nice to see these facilities and these former industrial properties kind of come into this next wave of automation and technology.
Oh, that's pretty neat. And where I parked my sailboat over at Pier 39, there's one of the last Liberty ships that could have been built in that factory, I guess. I'm not sure if there was multiple factories, but that was one way that they overcame all of those U-boats, the German submarines, is they just made tons and tons of these ships, so there's too many for them to catch. I think maybe Kennedy was Kennedy on one of those? I'm not sure, but yeah.
So anyways, so Viridi is now producing and assembling product on both coasts. We have a pretty wide, I would say, commercial rollout in California. And I would say that the California government has been incredibly welcoming, and the California Energy Commission has actually kind of involved themselves in helping us get introduced to the different markets and the different users in California. So, I had never done business in California, and to date, I've had a really nice experience, and I'm very encouraged about that market.
Great. That's good. And so what kind of application are you using your batteries for right now?
So Sean, our systems, right, are best from like 150 kilowatt hours all the way up to about 10 meg. Like that's kind of our range. And we really have the only system that can go into a building or an occupied space at scale. So one of the examples of an installation we're doing in about 8 to 10 weeks, we're putting in 3.5 megawatt hours of batteries into a new subsidized housing development so that they can add a fossil energy source coming into the new development. But 3.5 meg inside the building is probably the largest indoor installation in the country. And it's being done through the permitting through New York State and the permitting through the local fire authority.
Okay, so 3.5 megawatt hours inside of a building. So yeah, a lot of people put them in containers. And another thing too is there is the biggest energy storage system in the world. I think it's still the biggest, but I don't know if it's operating anymore. But it's some gigawatt hours, and it's sort of in a building, but it's an old natural gas plant. So it's not like any kind of building where people would be or anything like that. So that's a lot of, codes to follow too, being inside of a building. And I'm sure that you have UL 9540A, because when you read all these, like it would be the International Fire Code, NFPA 855, that's the standard for stationary energy storage systems. If you read it, at first you think like, oh man, there's all these rules I got to do. And then at the end it says it's exempt if you have large scale fire testing, which is UL 9540A. And I bet you're super familiar with the UL 9540A.
I am so familiar, my head is like, blah.
I know, I probably shouldn't have said that.
I would
probably
say
like,
this.
we're giving you nightmares.
No, it's okay. It's okay. And I'll tell you, the biggest challenge we've had, John, in going through that testing is not how we pass it. Mm-hmm. It's that the test is really set up to be observational to measure the amount of release so you know the distance you have to place the system from a combustible source. And because we have no release, like nothing comes out of our pack in a catastrophic failure, we've kind of paved new road is what's happened, right? Is we've created new standards for those labs to adapt to. And whenever you're the first one, it's good commercially, but it's a little tough when you're going through these regulations, and we're through it.
Great.
But the reason we can go in a building is when we force a cell into thermal runaway, we don't get propagation. So inside of that pack, we control thermal runaway, and we prevent it from transferring energy to the next cell. And that's really why we're so unique in this space.
So you are preventing cell-to-cell thermal runaway?
Cell-to-cell propagation.
Cell-to-cell propagation. That's very unusual.
We're the only ones.
That should be on the front page of the newspaper, especially in Richmond.
Well, John, your podcast is a great way to go from this incredible thing we've designed to people actually knowing about it. So,
Do you have any plans for residential energy storage systems?
Yes. So we have a 50, 100, 150 system that is on residential voltage. We're installing a number of these. So you talk about a crazy market. So one of the markets that's developing for us right now are sewage lift stations in residential communities. So where you have a residential community that is above the gravity feed of the sewer, you actually have a lift station that the sewage goes to, and then it gets pumped into the sewer.
Wow. Okay, that's an interesting application.
These lift stations are remote. They're typically in wooded areas or places that aren't easy to get to. And monitoring, control, and support a 150 kilowatt hour battery system with the great thing is you take technology that's in most cases 50 to 80 years old, because our battery system will control anything as long as you plug into it. So even though the lift station is 50 years old, the energy use profiles, they know if a pump's going bad, they know if it's not, they know if power's gone out. Like, they've got full visibility and control without changing the physical equipment. And we're doing this in Erie County right now in upstate New York, and we're getting ready to roll it out across California and New York.
So that's a very interesting application. I'm here, we're building a solar training center. You might hear some hammers and saws in the background, which is exciting. It's exciting to see things get done and work in this fast-growing industry. But what I was wondering about too is the application of the sewer lift station. So like pretty much you have sewage and you have to pump it up over a hill or something like that. And is it going to be grid connected? I would imagine it's probably grid connected. Is it primarily for backup? Or is it to reduce demand charges, or what's the application as far as that's concerned?
Yeah, so all of these stations today are grid connected, but they're typically grid connected on, a fairly unreliable connection because it's off and off of a system, and it might be the only connected load in a certain area, right? So there might be a half a mile of distance around it without any other connected loads. So they're currently using diesel gensets as backup. The problem with the diesel is that they don't know if it doesn't start until they get a notice from the next pumping station that it's either not getting flow or it's getting too much or there's something going on. So there's a huge technology gap in the timing of when these systems were installed. But more importantly, when you put our system in, you get an energy management system. So now on startup of the pump, I take away all the peak load. On shutdown of the pump, I make sure that it's getting the right voltage so there's not a sag or a peak that's going to cause the motor to burn up. And then what I'm doing is I'm reading on a constant basis energy flow coming out of the equipment. So if I get an energy spike that's not normal, my IoT and the algorithms are picking that up, and they're saying to the operator, there might be a winding or a motor or a pump that's going bad because you should be running at 10 amps constant load and you're running to 15 or 14 or 7 or 8. So the way the IoT system works is it learns the energy profile of that connected load, and then it gives you notice when you're outside of that profile. And even, what happened to us, Sean, was one of these stations, people were plugging into the station in the woods to power all kinds of goofy stuff. And the county didn't know. And they were
like they're illegally stealing electricity.
Yeah, they were tapping into it because there was no power around, so they were tapping into that control box, and they didn't know. And the minute we hooked up to it, we're like, something's going on here because your equipment says you should only be using, constant load of about 18 amps, and you're using 50. And that's what it was.
Okay, that's really interesting. So it sounds like you have a software and an energy management system. Is that something that's a Viridi product then?
It's a Viridi product. We acquired essentially a company that had the technology, and then we've kind of I wouldn't say reinvented it, but we've readapted it to our program. And the technology was originally was designed for SoCal Edison to use on high voltage transmission lines. And it was going to read wind, temperature, voltage, and then anomalies. So very sophisticated kind of algorithms and software that are built into it. The unit has an onboard computer, so it does computing at the site, which is really important for us. And then it has a FERC-approved transmission protocol so that we're licensed on every cell network, including the emergency communication network for cells. And we can run on any kind of Wi-Fi, and we can run on Starlink. So very flexible communication platforms, but a lot of real-time computing at the site, which reduces significantly the amount of information you have to transmit. And it also increases security dramatically because what happens is we only transmit 4 packets of information, even though you need 5. So you get the 4, and then you have to ping the device back to get the fifth.
Oh,
It's very hard to hack the information because you can't get it all unless you have the authorization, algorithm.
yeah, we don't want the North Koreans hacking our sewer systems. That would be
We don't want anybody hacking anything for any reason.
for hacking anything, yeah. And this sounds like a pretty good application and a good time to explain something too, which could have applications for small systems, like what you were just talking about with, the sewage pumping stations, and even like huge transmission lines. And with the huge transmission lines, they often call it transmission and distribution deferral. And you take an energy management system, and let's say that instead of running, we could give an example of 10 amps or 100 amps or whatever. Let me just do 10 just to make a round number for education's sake. And it could be like 10,000 or whatever. And so you got 10 amps and you are bursting that 10 amps half the time it's on, half the time it's off. But if you ran 5 amps continuously, you would have 4 times less losses from voltage drop. And that's just the relationship with voltage and current and voltage drop. So if you use batteries like that and you don't have to draw as much, you'll lower your demand charges. And that's one of the reasons they have demand charges, is because when you're drawing more current, there's more losses. And it's harder to make everything run at once. An example that I often give too is the average US house uses 200 amp service and 10,000 kilowatt hours per year. And if you do the math to figure out what your average current is, so not drawing 200 amps and then here and 0 amps there, or it would be less than 5 amps, 4 point something amps on average. So if you had a bunch of batteries at your house, even if you didn't have solar, you could survive off of a 5 amp service.
But Sean, let's take that one step further, right?
That sounds great. Yep.
If you put batteries at every residential home, and you've got a 200 amp capacity and you've got a 5 amp actual usage, I can now take you from an average draw of 5 amps to an average draw of 25 or 30 amps. And you can add EV charging, electrification, get rid of gas without changing the connected load. Like, we don't need to change wires and poles if we put storage in a distributed place so that the batteries take energy when we aren't. And you can go from using 3 units of electricity when we make 10 to using 6 units of electricity and still make 10, right? We can make a huge step towards electrification without generation, transmission, distribution, or connected load, just by leveraging the capacity in the existing system. That's it. Your example is like right on. And look at Jigger Shaw's been talking about this every time he's at a conference. But we got to get people to understand that capacity is not our challenge today with the electric grid. It's utilization. We have a lot of capacity, but without storage, you can't increase the utilization because of time of day. We're humans. We do stuff all at the same time.
Yeah, and so I was just thinking too, instead of adding all the electric cars and stuff, another way of looking at it is you've got one house on a 200 amp service, 5 goes into 240 times. So I need to add another 39 houses next door to mine off of my 200 amp service.
There you go.
Then if I could stick some solar on the roof, then all of a sudden, maybe I have 80 or 100 houses working off a 200 amp service.
I mean, there is no reason that commercial and residential structures, the grid should be the backup. Between storage and solar,
Exactly, yeah.
we can take the load off the grid. And then if you have 100% load factor industries like AI, allow those industries to take the power at 100% load factor, because we're going to remove all of this peak load, not consistent load, from the grid. And it'll work.
Yeah.
And look, the 2 things that we were missing, which selfishly I'm going to promote that Viridi solved, was energy density and safety. Right? We had energy density in lithium ion cells, but we didn't have safety. So we combined the technology of that cell, which is very energy dense, with a pack system that's fail-safe. Everything goes wrong, everything goes to pot, nothing happens.
Great.
We should expect that in our economy.
So the energy density, I guess you have probably lithium iron phosphate is what you're using?
Nope, we use lithium NMC.
NMC, so lithium, nickel, manganese, cobalt oxide.
Yes.
And so that's the type of battery cell that a lot of the cars have with the long range, and a lot of the energy storage systems that are stationary are not using the NMC
Because of safety.
because of safety. And then that's why I was just kind of assuming you were using LFP, because that one has less energy. So it's, anything that has less energy is considered safer. I mean, just in general, but not without your secret sauce. So what's the secret sauce?
Okay, so, but before I get into the secret, people actually know what those initials mean. So thank you, because typically I'd have to do a 10-minute explanation on that. So that was really good. So all we did, Sean, was this. And look, I'm not a chemist. I don't have an engineering degree, but I think I'm an engineer through practice. And I'm a very practical person when it comes to challenges. All right, if we need to fix something, we have to recreate the failure enough times that we can get to a point where we can do it or we know we can't. So the way we did this was we blew up a lot of packs, like $5 million worth of cells.
Oh, that must have been fun.
Unbelievable.
Yeah, do you wait for 4th of July or do you prefer New Year's Eve?
So here's what happened, right, is the first 50 kilowatt hour pack that we set off didn't go very well. Like it was a spectacular failure in that it fully propagated and let go. We had every fire department in all of upstate New York respond to our site. And in the middle of a great big parking lot with a fire hydrant and a fire hose, there was a pack that's about the size of a big suitcase on a metal stand, burning uncontrollably, but that was it. And the fire department trucks all circled around it, just almost like a cartoon. They were rung all the way around this little pack because they didn't understand it and explained it to them. But after that, the fire department, to their credit, said, look, John, every time you test, call us, and we're going to come on site and drill. And if the pack fails, we're going to practice putting it out. And if it passes, our teams will be here to kind of understand the technology.
That's a great idea. Yeah.
And it was really good, Sean. And I got to tell you, it's big credit to the city administration and the people that run Buffalo, because that was not an easy thing to do, but they did it because they knew electrification was coming and they wanted to understand it. So all we did, Sean, in that whole process is we kept using material science inside the pack next to the cell to figure out how we could capture that energy and prevent it from translating to the next cell. And the bad news about an NMC cell is that when it goes off, 600-700 Celsius in heat, particulate, and you get a sound wave, right? When that cell lets go, you get a concussive force, which is a sound wave that transmits. The good news about the cell is all that happens in about 1.5 seconds. It's an instantaneous release of energy. And if you can hold that energy for 2 to 3 seconds, you can abate the propagation or the transfer of that energy to the next cell. And that's what we did. We used certain solid materials, which are like phenolic plates. We used liquid, basically distilled water in a pouch system that kind of surrounds the module. And then we used a spacing protocol so that as that cell lets go, the energy can basically dissipate and not point load to one location. And those three things combined in our 9548 test in the lab, we had two 18650s go into thermal runaway next to each other, and we controlled that event and prevented propagation. So when you measured it, there was no gas, no heat, and no visible signs that came out of the pack, to the extent that we did the cheesecloth test. We put cheesecloth over the pack after it was wired up for a residential 9540A, and we did not discolor the cheesecloth, which, according to UL, they said it's never been done on a module or a pack in their lab.
Wow, that's something else. So I know that in the International Residential Code, they word it a little bit differently in the 2021 and 2024, but it essentially says right at the beginning that you don't have to follow the section on energy storage when you have something that's marked for residential use in dwelling units. And I've always told people that there's no such thing, that you can't get a battery that's marked for residential use in dwelling units. Is yours going to get that mark?
It is. It is.
Oh,
Now,
wow.
we didn't do it yet because we did the 9548 for commercial installations. We did the residential test as almost a, we're here anyways, just throw the cheesecloth on it.
Sure.
We're going to go back into UL and we're going to specifically run that test for the residential.
Okay, great. So that pretty much what that means is you don't have to follow all those rules. So you can put them in any room in your house. You could put as many kilowatt hours as you want because you're not going to have them catching each other on fire. So
Yes.
that's pretty cool. That's like kind of really important news. Probably all the newspapers are going to listen to this podcast and call you up and make a big article now. Has this been announced already?
So the funny thing is, Shada, so I'm going to tell you what our challenge is, and maybe you can help with it. I know you can help with it just by the viewers you have on your podcast. When we were going through all this, I was completely convinced that there were 5 or 6 other companies in the country or kind of in North America doing the same thing. So we were very quiet. We were very secretive about what we were doing. Once we passed all the tests, there wasn't anybody else who emerged who had done it. Unfortunately, we were the best kept secret in the energy industry at that point.
Wow.
So we are rolling out. We're rolling out with big kind of multi-platform customers. We've got, probably plus or minus 100 megawatt hours of systems that are installed and in the field today. But we need to tell our story. Like, we really need to find the right audiences to get this to. And, this whole concept of VPPs, this is how you do VPP. Like, if you can put 150, 300, 450 kilowatt hours in a commercial building, well, in a very small urban area, I can install 30, 40, 50 megawatt hours of connected systems that the utility can control in 3 seconds. You hit a button, my IoT will take the load offline and put the load online. It'll take draw, it'll reduce draw. Whatever the engineering parameters are for the grid operator, you can accomplish those now in very densely populated urban areas without trying to stack shipping containers in parking spots.
Yeah, and then this would be another way too that people could participate that don't have rooftops for solar and all that kind of stuff, that maybe even living in a condominium or something like that. You could just have a battery that you wheel into your house, and then when you move, maybe you could take it with you. I mean, you would have to have an interconnection agreement and all that kind of stuff. But, we do have the potential for the technology to make that work. In Germany, they're even doing balcony solar with batteries. So, their rules are much different over there. And I'm not sure how they go about, the thermal runaway and propagation and all that kind of stuff. And I know a lot of the bad press for that actually comes from people making homemade scooters with batteries that they find on Alibaba, and they get a soldering iron over in New York City, something like that. But that's just, that would be so awesome if you could not have to go by the International Residential Code with your energy storage systems and then just put them wherever you want in your house.
That's our objective. So any place you have a hot water device or a utility room, you should be able to drop a pack in there and turn your house into part of the energy management system for the entire grid.
I heard of somebody that came up with a stove oven, and they had a kilowatt hour of batteries in it, and it was electric, and they could just plug it into any 120 volt outlet, and they wouldn't need, special 240 volt wiring or anything like that. And they were doing it, I think, because if it's a kilowatt hour or less, they don't have to go by the IRC, the International Residential Code. But with yours, potentially you could go over a kilowatt hour.
Well, and here's the thing is, the code is there for a reason, right? We don't want residential homes to burn down. We don't want kids at risk. We don't want apartment buildings. And when you do things that are below the threshold of a code, inherently you're going to have a problem. Because even a kilowatt hour battery, you've seen this, you've seen what they look like when they go off. It will burn down an apartment. Even though it doesn't sound like a lot of energy, it's a lot of energy if it releases in an uncontrolled way. So if we want this to happen and we want electrification to become not what we all hope for, but what we just do every day, like fossil, it has to be safe. Like, we cannot put product in the market where every day we're trying to defend against another news article where, a child or an elderly person or a housing complex was put at risk.
So maybe we could also kind of clarify what this means and like propagation. So you have an energy storage system and it has a bunch of batteries in it. And 18650 is what you're making. So it's 18 by 65 millimeters. What is that? Somewhere around the size of a D battery or C battery or one of the.
Yeah, it's a little bigger than a double A, right? Between a double A and a C, probably.
Yeah, between a double A and a C. It's like maybe a little bit longer than a double A and a little bit thicker. And so if one of these battery cells catches on fire with just about every other energy storage system, it catches its next door neighbor on fire. And I shouldn't even say fire because it gets hot. If it gets hot, the other one gets hot. And one of the things that a lot of these batteries do is they go through this test, and it determines how close they can put the energy storage systems together. And most people do go through UL 9540A. So they get their energy storage system or the battery module. And if they don't have UL 9540A, they can still use it, but they have to keep them 3 feet apart. And most people go through the testing, you follow instructions, and you can put them closer than 3 feet apart, whatever the instructions say. And that's because pretty much all of them, you get one cell that gets really hot, the cell next to it gets hot. And that's the thing you don't want to have. There's like one energy storage system, like up to 20 kilowatt hours for residential, getting another one hot, going into that thermal runaway and propagating from one energy storage system to another. And they pretty much all propagate from one cell to another. But if it's one cell to another, they go through all this testing and they say, well, that's still okay to put in your house. But if you don't even go from one cell to the next cell, that's pretty amazing. And that's, everybody would love to have that. The International Residential Code too, that's for, dwellings, is kind of interesting too how it says that, because when you first read it, it's like marked for residential use. Isn't everything for residential marked for residential use? But it's not. And as far as I know, nobody has it, and you almost have it.
Yes.
Do you have a date we'll throw a party there in Buffalo and Richmond?
In my experience, I've stopped trying to predict UL because I have very aggressive dates and they have what their dates are going to be. But I would believe we will be fully through that process by the end of the first quarter, without exception.
Great. And so you're going through UL. There's a lot of different testing labs that can test to UL, and you're going through UL.
So we're using the UL lab for this 9540 and the subsequent residential testing. Yes.
Okay, great. Because I know some companies use different labs to do the UL test because they think they're easier. So you're just.
Well, I mean, look at there's CSA, there's Intertech, there's a bunch of them. The reality is, and you know this because you've been in it for so long, they all test to the standards that they collectively create. Right. So those labs agree on standards, and the reason they do that is that if CSA certifies to a standard, they don't want UL not to accept it. And if Intertech does it, they want CSA to accept it. So most of these products go through different labs, some because of geographical convenience. Like, there's a testing lab that can physically do our product that's in the same region. And sometimes you want the expertise at a certain facility because, they have really good battery scientists at this CSA facility in Phoenix, for example. So you go there because the conversation is easier because they know what they're testing. Whereas there's another lab that might be testing toasters or electric vehicles or scooters or whatever.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
So are you using your batteries for EVs at all?
Well, we're not using them for the EVs, but we're doing a lot of deployments for EV charging. So you can take my system, plug, EV chargers into it, and have remote charging for office buildings and complexes and everything else. And we're talking to California about the Olympics right now and using one of the container systems to do 2 level 3 bus chargers remotely.
Okay, great. Yeah. Maybe they can do the high jump over one of your energy storage systems.
Give it a try.
Like the size of your energy storage system, would it be more of like a high jump or a pole vault?
Well, so we have a 1.2 megawatt 20-foot container, which I would call a shot put, right?
Okay,
it's kind of a big block of energy.
So kind of between a high jump and a pole vault, probably.
Yeah. But the 150, the mobile 150, I think is kind of a pole vault because it's very flexible. You can almost put it anywhere.
Okay, great. Well, I hope they do that. And do you have any more information about the Olympics too? Or?
We're working on it, right? And the challenge is that almost every group we're talking to has me under like 27 different NDAs. I'm allowed to say Olympics and I'm allowed to say California, but that's the end of it.
And so I know the rumors are Los Angeles. Can you say the year?
Well, yeah, it's coming up. I think I'm pretty sure it's 28, right? It's Los Angeles in 2028. Yeah.
Okay. Yeah. Sounds good to me. Maybe I'll go down there, but I'm a little bit ways away from Los Angeles there.
You know what's funny about California is people completely discount the fact that it's basically a country unto itself. Like, it's so damn big.
I think we're about the size of Japan, like as far as how much area we have.
Pretty much. Yeah. So when you're in San Francisco, LA is not exactly around the corner.
Yeah. You could say it's like 5 hours if you're driving a sports car at midnight. And so usually you're going to have traffic on the north and the south side. And so you call it 7, maybe something like that. Yeah. And then that makes it a lot easier just to fly. But I can't, it would just be really cool if we had some kind of transportation where you didn't have to get on an airplane and I could just, get on the high-speed train or something like that. It's kind of crazy how, you go to Europe and China and stuff, and it's like these high-speed trains just get you everywhere. And for some reason, we're just stuck in some kind of politics, I can't figure out why that every other country, or not every other country, but these other countries do it all the time, real easy, and it's fun. And it's
Yeah, I think, part of it, Sean, is because we are 50 different states and we have a federal government, it is more complicated to do big infrastructure in the U.S. than in other countries. We only have one administration to deal with, essentially. And I think, too, look, as technology changes here and things are advancing as fast as they are, the cost of those systems are going to come way down. And as that happens, we're going to start putting them in. And as weird as it is, our systems will be the most advanced in the world at that point because everybody else has had them for 20 and 30 years, and they're older technology. So,
yeah, man, you have a positive attitude. I love it.
What else are we going to do?
So speaking of, scaling up and all that kind of stuff, how is it looking for your factories? And how are you dealing too with, speaking of optimism, I always like being optimistic, dealing with the change in the tax credits and all that kind of stuff?
Yeah, Sean, I think, you obviously were in the administration that got all this started for us and kind of got the nation to recognize that we can do better and we should do better. And no matter who we are, where we are, what we do, things are going to change every day. And if you're in business and you're serious about it, you have to be in a position where you can adapt to whatever the code and the regulation is. I think fortunately for us, storage probably came out not unscathed, but pretty close. And the accelerated depreciation kind of offset any challenge to the storage credits. We do have a lot of issues with foreign materials right now that we're working through. And as far as Viridi is concerned, we will get through that. We are pretty much compliant right now with all the Build in America percentages, and we're going to keep getting better on that. But today, our PAC system is still eligible for the 40% ITC, which is not the case for most of the market right now. Mm-hmm. But listen, if buying our PAC system is not a better commercial decision than using fossil, we failed. So we need to be a better option than fossil in any economic regulatory environment. And that's our objective. Our objective is to be the safest, most energy resilient, lowest cost solution for power, bar none.
Great.
And look, we got to get there, right? That's the challenge to businesses. If you're not better, you're not going to be there.
Yeah, great. I agree. Yeah, I think that, even without the tax credits and all that kind of stuff, we're going to survive. It'll be nice to keep it, but there's a lot of countries in this world that don't have all those tax credits and things like that. And I'm glad that you're so positive about that. And manufacturing in the United States, where we used to build the world and now it's coming back. And it is kind of neat too that you're using these old buildings from over 100 years ago that are made out of bricks. I could see bricks in your background right now, and they're coming back. And I guess you could say back then it was more like the Industrial Revolution, and now I don't even know what to call it.
It's the energy. This is an energy revolution, John. The really cool thing about the next 10 years in the space that you're in right now, this is the largest unaddressed market in the history of humankind. We are going to repower the world. That hasn't happened in 150 years. Yeah. And we're sitting in the middle of it, and I don't think anybody appreciates it because it's what we do every day. But The next 10 years, you're going to see energy as we know it completely transformed, and the costs are going to come down. Resiliency is going to be an absolute expectation in delivery every day, and the safety and flexibility of our economic system is going to be far better off.
Yeah, it's going to happen no matter what. And I think probably electricity prices will go up without the tax credits. Maybe that's what's going to end up happening.
In any transition, things, right, there's a lot of market forces that cause changes. But if 10 years from today, we don't have lower electric prices, we didn't do our job, right? Because if more people are buying units of electricity, that has to bring down the cost.
Yep.
Once we transition to that.
Yeah, and with all this, like scaling up of manufacturing brings down the prices. For solar, they called it Swanson's Law, and I don't know what to call it for energy storage, but it's the same thing pretty much.
We'll call it Sean's Law. How's that?
Okay, all right. Yeah, I'll let you spread the word there.
Very well.
Yeah. Great. Okay, well, this has been a really interesting conversation. I always like talking to you. Let's see, is there any other things that you want to cover right now?
No, I just think, Sean, the more we can talk about virtual power plants, distributed storage, optimizing the energy that we currently have in the grid, the quicker we're going to see those energy costs stabilize and start to come down. Because look at it today, right? Just hypothetically, we generate 10 units of electricity, we transmit it, we distribute it, and we put it at the front of the meter, but we only buy 3. Well, if we can turn 3 into 6 without adding infrastructure, we just brought down the cost of electricity. And we can turn 3 into 6 just by putting storage behind the meter.
Great.
That's my final thought as you're talking to this crazy guy in Buffalo.
Well, thank you so much, crazy guy, John Williams, Chairman and CEO at Viridi Parente, for making the world a better place, making these batteries that will be super, super safe, that we can put in the baby's room, perhaps, at least according to the codes. I would probably at least put it in like the teenager's room.
Teenagers,
Oh, maybe they would try messing with it, though. I don't know. But great. Yeah, these are the kinds of things that we need, and that's a good leadership, American innovation, and then the old Ford plant with Rosie the Riveter, and you're in the GM plant over there in Buffalo right now. And I can't wait to see this technology in everyone's house. So hurry up, everyone. Get one in your house. Get a virtual power plant. That's a VPP, and use the IoT, the Internet of Things, and make it happen. Thanks, John.
John, I couldn't have summarized it any better. Thank you.
All right, cool. And thanks for listening to Shawn White's Solar and Energy Storage Podcast, where you will get jokes, optimism, and a lot of education. So go to SolarSEAN.com, get yourself educated, get NABCEP certified, get the NABCEP ESIP. That's the Energy Storage Installation Professional Certification. And I have a class for that. Check it out. Woo!